Hey everyone, and welcome back. So up until now, we've pretty much been teaching our Arduino how to talk. Blinking lights, making noises. But today we're giving it a brand new sense. We're going to teach it how to listen to the world around it. And the key to all of this is one simple but incredibly powerful command, digital read function.
So here's the game plan. First, we'll get a handle on the whole idea of digital input versus output. Then we'll really zoom in on the digital read command itself. After that, it's time to get our hands dirty with a classic push-button project. We'll code it up step by step, and then, to wrap things up, I've got a little challenge for you to test what you've learned. All right, let's get into it.
Okay, first things first. Before we can write any code, we really need to understand this core concept, the difference between making our Arduino talk and teaching it how to listen.
Think of it like this. On the left, you've got output. That's the digital write command we've used before. This is the Arduino talking. It sends a signal out to the world. It tells an LED, hey, turn on, by sending a high 5-volt signal. Or it says turn off with a low 0-volt signal. But on the right, that's our focus for today, input. This is digital read, and it's all about listening. It reads signals coming in from a sensor or, in our case, a button. It's still looking for those same high or low states, but this time it's on the receiving end. So let's get right to the heart of it. How exactly does this digital read command work its magic? At its core, digital read.function is a function that does one really simple thing. It peeks at a specific digital pin and reports back what it sees. Is the voltage on that pin high or is it low? That's it. That's the whole job. It's the fundamental way your Arduino can sense and react to its environment.
And check out the syntax. It's so clean and simple. You just call the function digital read, tell it which pin you want it to listen to, and then you take its answer, that high or low value, and you store it in a variable. But hold on a second. Why are we storing it in an int, an integer variable?
And this is where it all clicks. See, while we talk about high and low signals in electronics, when we get into the code, those concepts get turned into numbers. A high signal is just the number 1, and a low signal, that's the number 0. And since 1 and 0 are integers, it makes perfect sense to save the result of our reading in an int variable. This little translation is what makes using inputs in our code so easy.
All right, that's enough theory for now. Honestly, the best way to really get this stuff is to just build something. So, let's get our project for today started. So here's our mission, and it's a classic for a reason. We're going to connect a simple push button to our Arduino, and when we push that button, we want to control that tiny little LED that's already built right onto the board, the one on pin 13.
Okay, time to fire up the software. Let's start writing the code to bring this circuit to life, one piece at a time.
So the very first thing we have to do, inside our void setup, is tell the Arduino what we're planning for our pins. We'll use pin 12 for our button. But hang on, look closely. We're not just writing input. We're using this special mode called input_pullup. So what in the world is that?
Well, this solves a really common problem. If you just leave a digital pin unconnected, it can float, which means it might randomly read high or low, giving you garbage data. Input pullup is the fix. It activates a tiny hidden resistor inside the Arduino that pulls the pin's state up to high by default. So it just sits there reliably high until our button press connects that pin to ground, which then yanks the signal down to low. It's a super clean, super stable way to read a button.
Okay, now let's jump into our void loop. Since the pin is all set up, we just need to constantly check its status, and we do it with this line right here. We create an integer variable called button state, and every single time the loop runs, we fill it with the result of digital read 12. This line is basically asking over and over again, hey, pin 12, are you high or low right now? And then it saves that answer.
But how do we actually know it's working? Before we even think about controlling an LED, we can use an amazing debugging tool, the serial monitor. Just by adding serial.println button state, we can print the value of that variable right to our computer screen. It's literally like we're looking inside the Arduino's brain to see what it's hearing in real time.
So, we upload this code, open the serial monitor, and don't touch a thing. What do we see? A constant stream of 1s scrolling by. And why? Because our input pullup is doing its job perfectly, holding that pin in a high state. And as we just learned, a high state gets read as the integer 1. It works.
And now, for the magic moment. The instant you press that button, you connect pin 12 to ground, which pulls the signal low. And look at the monitor. The output immediately flips to a stream of zeros. Why? Because a low state is read as the integer 0.
This is it. We now have solid, digital proof that our input is working exactly the way we want it to.
Okay, this is the crucial part. We know we can listen reliably, so the last step is to take what we're hearing from that button and use it to control our output, the LED. Let's make that connection. Believe it or not, we only need 2 more lines of code. First, back in setup, we have to declare pin 13, the pin for the onboard LED, as an output. Then, down in our looping, we add this absolutely beautiful line, digital write 13 button state. Think about what this is doing. We're telling the Arduino to write whatever value it just read, R1 or R0, directly to the LED.
Let's break that down. When our button is not pressed, button state is 1. So that line of code becomes digital write 13.1, which of course turns the LED on. But when the button is pressed, button state flips to 0. So the code becomes digital write 13.0, which turns the LED off. We've directly tied the input state to the output state.
And when you upload that final code, this is exactly what you see. The LED is just on by default. Then you press the button and it turns off. Now I know that might feel a little backwards at first, but it makes perfect sense when you remember our input pull-up is holding the pin high or on by default. The most important thing is, we did it. We successfully taught our Arduino to listen and react.
Okay, you've seen all the pieces of the puzzle come together, so now it's time for a quick little pop quiz to make sure it all sunk in.
On your screen right now are 2 very short programs. Both of them are trying to do the exact same thing we just did, use a button on pin 12 to control the LED on pin 13. But here's the catch. One of them has a critical error. So you've got program 1 on the left and program 2 on the right. Take a really close look at the setup function in each one.
So here's the final question for you today. Which one of these 2 programs will actually work, and what essential piece of code is missing from the one that's going to fail? Think back to everything we have to tell the Arduino before that main loop even starts to run. I'll let you puzzle that one out. Thanks for diving into this with me, and I'll catch you in the next one.